How to choose the right data science and machine learning platform? It's a pretty complex question, but let's break it down to make it simple. First, let's start with defining what is data science and machine learning, and let's go to Gartner for that. Gartner defines it as being the integrated set of code-based libraries and low-code tools that support the independent use and collaboration between data scientists and their business and IT counterparts through all stages of the data lifecycle. I know, but it's going to get worse before it gets better. So let's break down now the data science lifecycle. So it goes from business understanding, data prep, modeling, to deployment and MLOps. Yeah, we made it more complicated, but let's try to simplify it by looking at an example. So let's take the example of Booking.com. Let's take the objective of, for example, increasing booking conversion. And let's go through the 5 steps. So first, when it comes to business understanding, the goal here is to increase conversion rate of users searching for hotels, but not completing bookings. Second, we move to data prep. So here, what we're going to do is to gather data from user sessions. These are pages visited, search filters used, time spent per listing, and combine it with historical booking patterns, things like seasonality, location, and pricing data. Third, we're going to do the modeling. And here we have ML models that are trained to predict the likelihood of a user completing a booking based on behavioral signals and context. Things like mobile versus desktop users, solo versus group travelers. And fourth is the deployment phase. So here we're doing predictions that are used in real time to personalize hotel listings. Example, we're highlighting some deals, or we're showing some urgency, like 2 rooms left for certain bookings, or offering discounts to hesitant users. And fifth is the MLOps part. So models here are monitored for drift as user behavior changes over time. Things like post-COVID are impacting these changes and periodically retrained to maintain accuracy. So why do data science and machine learning platforms matter? Well, they reduce time to model and they simplify experimentation. But most importantly, they put the power of machine learning in the hands of business users and not just data scientists. So for travel, there are so many use cases that can be applied here. Things like fraud detection and prevention, personalized travel recommendations, dynamic pricing optimization, intelligent chatbots and virtual agents, or things like demand forecasting for routes and inventory, and so much more. So how do you evaluate data science and ML platforms? And here we go again to Gartner. So Gartner defines 3 main things. So must-have capabilities for data science and machine learning platforms, standard capabilities, and then optional capabilities. There are 3 must-have capabilities that Gartner defines. So the first one is data import. This is the ability to connect to databases, data warehouses, or cloud storage to bring in structured or unstructured data. An example here would be ingesting booking records from Snowflake and traveler reviews from Amazon S3. The second must-have capability here is building and evaluating models using a broad ML toolkit. And here we're using machine learning algorithms like regression, trees, clustering to build models and compare performance. An example here would be using random forest or gradient boosting models to predict booking cancellation and seeing which one applies best for this specific scenario. And then third, it's the ability to deploy and serve models in production. So this is where you operationalize machine learning models to make real-time or batch prediction within apps or services. So the example here would be you're deploying a hotel recommendation model via API to personalize results on the travel website homepage. Let's look now at the standard capabilities. So the first one, and there are 5 of them here, is handling text, image, audio, and geospatial data. So this is building models using multiple data types beyond just structured tables. And the example here would be using customer review text and hotel location data to predict user satisfaction by region. The second here is low-code tools for non-experts. So this is the drag and drop capabilities, visual workloads for business users, and the ability to build models without coding. An example here would be a pricing manager using a visual tool to forecast travel demand during holidays. Third is Jupyter-style notebooks for data scientists. This is the ability to have interactive code-first environment for advanced data modeling and exploration. And here, a data scientist would be able to experiment with NLP and to classify support tickets, for example, using Python notebooks, all within a single console. The fourth capability here is lifecycle management to handle model drift, which is pretty common in machine learning. So here, we're tracking changes in data or performance over time, and this triggers model updates when needed. An example here would be you're retraining a hotel ranking model when traveler preferences shift due to a new travel trends. And fifth here is the MLOps ready deployment at scale. And these are the tools and infrastructure to manage deployment and monitoring of CI/CD for machine learning models. This is like, as an example, running multiple language-specific recommendations modeled for different country sites. And here are the optional capabilities, or these are like differentiators that are available with some vendors out there. So there's the ability for AutoML with data prep recommendations. So this simplifies the adoption of machine learning and data modeling, where you have automated suggestions for how to clean and prepare data and which models to try. Here, the engine is recommending you the best way to encode seasonal features in booking data. Simulation and optimization tooling. So these are tools to test different scenarios and find the best possible outcomes. It's simulating various discount strategies, for example, to optimize hotel occupancy rates during low season. SDKs for custom workflows, developer kits that enable custom integration and extend the platform. An example here would be integrating machine learning-based pricing recommendations directly into an internal revenue management system. And fourth is the Gen AI integration and prompt tracking. So these are the built-in tools to work with LLMs and track prompts, responses, and models. An example would be using Gen AI model to generate personalized travel itineraries and monitoring the prompt results. And fifth here is the explainability and model transparency tools. So these are features to visualize and interpret how a model makes prediction and highlighting which booking behaviors must most influence a traveler's likelihood to cancel, for example. So how do you choose the right platform for you? And here we have 9 steps before you buy that will help you decide which platform is the right one for you. So the first one is defining your users and their skill level. So you have to ask yourself, who's going to use the tool? Is it data scientists? Is it ML engineers, data analysts, or business users? And do you need low-code interfaces for notebooks, or do you need SDKs for customization? Second, you need to understand your use cases. So is it for predictive modeling? Is it computer vision? Is it NLP? Is it Gen AI? And based on that, that's going to condition the right tool to select. Do you need models that are operational in real time or analytical with batch processing? Third, you have to evaluate your lifecycle coverage. Do you need the entire data science and machine learning lifecycle? Do you need support for MLOps with things like retraining, drift detection, model retirement? And then integration and data access. So what data sources do you have? And can the solution connect to these data sources? Can it handle both structured and unstructured data if you need both at the same time? Deployment and scalability. Can you deploy models inside the platform and integrate them with different applications and different services of your business? Does it scale across environments, whether it's cloud, hybrid, or on-premises? And then collaboration and governance. So can teams collaborate, share assets, reuse code, data, and models? Does it have centralized governance, role-based access, auditability? And 7, AI and Gen AI capabilities. So does the platform support LLMs, prompt tracking, or Gen AI model management? 8th is the performance and cost efficiency. So how does the platform handle performance tuning, workload orchestration, cost control? And then 9, and the last point is about compliance and interoperability. So are explainability and compliance features built in? Does it support model transparency for regulated industries or not? So these are the 9 questions that will help you decide which solution is the right one for you. So now the question here is, what solutions are available in the market? And for this, we're going to turn to Gartner again. This is the Gartner Magic Quadrant for data science and machine learning platforms. There are challengers, leaders, visionaries, niche players. You could evaluate all of them. But for the purpose of this video, we're going to focus on just the leaders, and we're going to focus on 7 of them here. AWS, Databricks, Dataiku, DataRobot, Google with Vertex AI, and Microsoft with Azure ML. So AWS has a comprehensive suite. It's an integrated ecosystem that is the AWS ecosystem and has a strong developer community. The challenge here is the portfolio is a little bit complex. Databricks has the very famous Lakehouse architecture, centralized government, strong innovation pipeline, strong acquisitions in this space. But there is some friction reported by customers when it comes to performance tuning and management that you have to be cautious about. Dataiku, the strengths here, this is a collaborative platform with strong governance and a very clear GenAI strategy, but it has a smaller community and pretty confusing pricing model. DataRobot here is a very enterprise-friendly AI that's tailored and applied to simplicity, time to value, with a lot of out-of-the-box features that enable you to take advantage of the platform without added complexity. The cautions here are about licensing costs. Google with Vertex AI, the obvious strength here is the Gemini model of Google. They have a lot of innovations shipped every year, and it's a strong GCP ecosystem that you can leverage here. But the caution here is that it's very GCP centric. And then last but not the least, Microsoft with Azure ML with extensive foundation and model with a lot of collaboration with OpenAI, very strong educational offerings, and optimized hardware infrastructure for GenAI. But again, here, the caution here is portfolio fragmentation and the fact that this is also like very Microsoft centric as a solution. So, which of these solutions is the best one? And the answer here is that there is no one size fits all or magic bullet. It's all about trade-offs. So, if you get speed or flexibility, you get ease of use or depth, you get close, code, or click. And what matters the most here is where you are in your journey. What problems are you trying to solve? And what kind of superpowers your team needs right now? If you define that really well, then the choice will be easy to make. Thank you.